This is View Pre-Calculus. We're doing topic 4, which is rational functions, and this is video number 3 in the series. So for example 5, we have this big old quotient, right? We have a rational function, x squared minus 9x plus 14 divided by x squared minus 6x plus 5, all divided by another rational function, x squared minus 4 over x squared minus 7x plus 10. So the first thing I'd suggest you do is change this division to multiplication, right? When you do that, you flip the divisor, right? If you need the step where you write this as the other kind of division first, that's great. If you don't, also great, up to you. So up top, my x squared minus 9x plus 14 is going to stay the same, and so is my x squared minus 6x plus 5. But then I'm going to flip this divisor and make it multiplication, which means that the x squared minus 4x, which was on the top of that rational function, will now be on the bottom. Sorry, x squared minus 4. Sorry, and I think I said 4x a second ago, but you get the gist. And the x squared minus 7x plus 10 will end up on the top, right? So this is where I'm at now with multiplication. So now I want to factor all 4 of these polynomials and see what I can cancel. So let's start with top left. The x squared minus 9x plus 14 is going to factor into an x minus 2, x minus 7. I know this because I need things that multiply to 14 and add to a negative 9, and that's a negative 2 and a negative 7. If we do bottom left, x squared minus 6x plus 5 is going to be an x minus 1, x minus 5. Same argument, I need things that multiply to a positive 5, but add to a negative 6. When I factor top right, I'm going to get x minus 2, x minus 5. Right? And on the bottom, I'm going to get x plus 2, x minus 2, because that's a difference of squares. So let's see what we can cancel. So I can definitely cancel an x minus 5, and I can definitely cancel one of the x minus 2's, but that's it. The other x minus 2 is stuck because there's only one to cancel it with. So my final answer ends up being x minus 2 times x minus 7 over x minus 1 times x plus 2. That's fine. Right? That's the factored answer. Or if you want to FOIL everything out, you're going to get x squared minus 9x plus 14 over x squared plus x minus 2. Right? Also fine. All right, so that's our example 5. Let's move on to example 6. So example 6 is a little bit different because it's a fraction in your fraction, but you still need to get a common denominator. It's good times. All right, so this is something you're going to see when you get to calc down the road, so you might as well see a little bit of it now. So I have x plus h on top of x plus h plus 2 minus an x over an x plus 2 all over an h. So the trick is that I need a common denominator on the top, but the way denominators work is that x plus h plus 2 is a completely different number than x plus 2. You can't like add h over h to a fraction. If your brain says that you can, I can show you really quickly that you can't, right? So let's say that I have 3 over 4, right? So it is not okay to just add 10 on both floors, right? So 13 over 14 is not 3 over 4, right? You can times by 10 over 10, right? So like if you did 3 times 10 and 4 times 10, you'd get 30 over 40. Well, that is 3 over 4. That's okay, right? That's okay. But you can't add a number to the denominators and the numerators. That's not how it works. So, point being that even though these look kind of similar, they're actually not. This fraction is going to need the entire denominator from over here, the entire x plus h plus 2 over the x plus h plus 2. And this fraction is going to need the whole x plus 2 over x plus 2. And this guy's just going to kind of chill because the h is the least of my concerns right now. So now I'm going to clean up a bunch of stuff, right? So if I distribute the top here, right, I'm going to get x plus h times x plus 2. Well, when we FOIL that, right, because that's a binomial times another binomial, I'm going to get that this numerator is x squared plus outer will be a 2x, inner is an hx, last is a 2h. When I distribute this negative x over here, I'm going to get a negative x squared minus hx minus 2x, all over my nice fancy common denominator, x plus h plus 2 times x plus 2, all over this little h that's just chilling by itself. So now let's clean that top up a little bit. So I noticed that this x squared has a negative x squared later. those are going to sum to 0. I see this plus 2x has a minus 2x, those sum to 0. And I see this plus hx and this minus hx. So it looks to me like the only thing left on the top is a 2h. So this fraction is actually a 2h on top of this ugly, complicated mess, divided by, technically, an h over 1, because that's what h is. So as we've seen before, I'm going to flip and make my division multiplication by timesing by the reciprocal. So I get a 2h over x plus h plus 2 times x plus 2. And that's going to be times 1 over h, which means that these h's can actually cancel. And my final answer, after doing an awful lot of math in this problem, my final answer is going to be a 2 on top of x plus h plus 2 times x plus 2. Now, you could FOIL at the bottom if you want, but I'll go ahead and tell you that when you do this in calculator, you're going to be doing this where you plug a value of 0 in for h. And it's actually way easier if you don't distribute everything out. So that's the answer we want to get. Let's do one last example. We'll do an example 7, and then you're going to work on practice problems 1 through 7, and I'll help you out. All right, so example 7, which I think is arguably much easier than example 6 and example 5. So example 7, we have a bunch of monomials, meaning there is no sum or difference. It's just a bunch of multiplication and division. So 15 over x squared times x to the 5th over 12 times a 4 over x. So you could just multiply and get 15 times 4 is 60, and then 60 divided by 12 is 5. That's fine. It's entirely up to you. My suggestion is instead that you cancel factors. So I see this 4 on the top could cancel out of the 12, leaving me with a 3. And then I say, oh wait, but 3 would cancel with the 15, and I just get a 5. So the only number I'm going to get is a 5 on the top, right? I also see that I end up with an x to the 5th on the top and an x squared times an x on the bottom. That's an x to the 3rd. So if I clean everybody up, I get a 5x squared. Now, you could also write it as a 5x squared over 1, but if 1's on the bottom, we don't have to write it. If the 1's on the top, I absolutely have to write it because a 1 over 5 is not the same as just, let's say, a 5, okay? So that's example 7. You're going to work through practice problems 1 through 7, and we'll go over them.